All right. One of the things that I assumed everybody was aware of is this whole idea of triangle congruence. And again, I found out after it was the first time a lot of you had seen it. So we're going to go back and just talk about that. Come on. There we go. In order to prove that a triangle is congruent to another triangle, and what it means, we did talk about briefly, it means all the corresponding angles are the same measure, and all the corresponding sides are the same length. Okay? But you don't have to know all 6 things to prove congruence. And I'll show you a little bit a video that will show that in a minute. So the first thing, and you can draw whatever part of this you need in your notes. So the first one is side, side, side. And what this means is maybe that side equals that one. The second sides would be equal. And a third pair of sides could be equal. If you have enough information to show that, you can conclude these 2 triangles are congruent because of side, side, side. So write that one down. Draw your little triangles and show the dashes. He's asking, can I write them in a specific order? So you can see that if I flip these around, it's the same thing. Devin, if I flip this one around, it's the same thing. If I flip this one around, so this is the one, if you wrote it as side, angle, angle, that's correct also. They're not directional. Either direction is fine. I think that's the only one that has a specific order that I would notice if you switched it. Okay, the second one means you have a side, the angle in between it, and then another side. And it does have to be the angle in between the 2 congruent sides. It wouldn't be this one, or that's angle side, side, right? The order matters. And again, I'll show you a little animation that I found. I remember in the past I would be like, if you've got 2 things that are the same, and it was so hard. There's somebody who's made an animation of it that visually is easier to understand. So 2 sides and the included angle. When I say included, it means in between them. All right, the next one. Another way that you can prove 2 triangles are congruent without knowing all 6 parts. And when I say 6 parts, I mean congruent side, another congruent side, another congruent side. A congruent angle, another congruent angle, another congruent angle. You don't have to show all 6 things. It could be an angle, the side in between it, and then a second angle. And the side needs to be in between the 2 for it to be called angle, side, angle. The order matters. If you use the wrong one, you would get marked off. So you can see that the one that we're currently on and the next one both have 2 angles that you know and 1 side that you know, right? Both have 2 angles and a side. That order would matter. All right, the third one. This means you've got an angle, another angle that you know they're congruent, and then a side. The side is not between the 2 angles. If you have those pieces of information, you can conclude that your triangles are congruent. They are the same measures in a different location. Was anyone not here Friday who needs the papers? Do you have the papers already? Do you need it? Carlos, did you get the paper, the purple? Okay, we're not going to use this one very much. It is only on a right triangle that if I know the hypotenuse and one of the legs, I can conclude that they are congruent because that right angle creates so many other congruencies. All right, so once I can tell that you guys are done writing this down, we're going to scroll down. We're going to review the properties from the purple paper that we can use to show that some of these things are congruent. Today was a much more successful day when we got to proofs, I'm just saying. And then hopefully tomorrow will be even better. Yeah. Well, unless they just show us pictures just like this, how are we going to prove that two triangles are congruent? Well, there's lots of things that we talked about on Friday. Sometimes they do just give it to you. They just say, this side and this side are the same. It's in the given. Other times they'll give us this is a midpoint. So they'll maybe say, this is the midpoint. So then we can conclude that two things are equal. Or maybe they'll talk about the reflexive property, which I think is such a silly one, but we use it all the time. If you have the exact same side touching, AC equals AC. Why? The reflexive property. So again, in order to use these, some of it they'll just give you, or they'll give you a hint, and you can then conclude congruence. Okay, how can we prove that angles are congruent? Again, they might just give it to you at the beginning of the proof. If we can see that there are vertical angles, they're always equal. Alternate interior, alternate exterior, corresponding. Definition of angle bisector. Does anybody remember what it means to bisect an angle? Exactly in half. So it's not just cutting like uneven. If it says it's an angle bisector, it will create two congruent angles. And we'll talk about this on Wednesday. Okay, did everyone get what they needed to up above? Do I need to scroll up for anyone? And again, these are on the purple paper. Which one? Okay, yeah. If you're writing these down, that's okay, but they are already on that purple paper. They're on that side. We have all examples of them. Okay, so the next slide, I'm going to show you pictures of two triangles, and with the markings, or with the way they're drawn, I want you to decide, how could I prove they are congruent? You're either doing side, angle, side, 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 angle, side, angle. I'll have to go look. I think I missed one. Oh, just kidding. There's two that we cannot use, and there's some cool animations on them. If I know that three angles are congruent, it's not enough information. So AAA, don't use it. Don't call them. And the other one is side, side, angle. Backwards, it is a curse word to some people. That one doesn't work either. So if the information that you have is an angle and then two sides, you cannot, even if they look the same, they look congruent, mathematically you cannot prove it. We would need more information. And if we just have three angles, just think, they could be like 100 feet apart or 1 inch apart. Okay, so let me show you the animation of this one, of these two things. I think they're helpful. I did put them on canvas, so. This is why side angle does not work.
So now that we've covered the 5 triangle congruence theorems, you may be asking, what about angle side, side?
See, you're not going to forget that, right?
Please
That's funny.
don't be uptight. Okay, so now let's go ahead and explore why angle side, side would not work as a triangle congruence theorem. So if we have a set of corresponding angles that are congruent and a set of corresponding sides that are congruent. Okay, so we have two sets. We have an angle followed by 2 consecutive congruent sides. The issue is...
Look at 7 and 8. We'll look at 9 in a minute. But it's a right triangle, so we can use the right triangle one. Otherwise, it's a no-no. Yep, let's look at number 7. Can you prove with what they've given you or with how it's drawn that they are congruent? And if so, which one would you use? Side, 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 angle, side, Angle, angle, side. I always miss one. I don't know which one I'm missing. Okay, compare with your neighbor. See which one they picked. Show your neighbor. Look over their shoulder if they're being shy. Baxter, what do you think it is? But it only tells me one side and one angle, so what's your second side? The reflexive. Side, angle, side. If you concluded something else, it wasn't given. You stretched a little too far. Okay, number 8. This one should be pretty fast. Write down what you think number 8. How can you prove they are congruent? Show your neighbor. Haley, what do you think on number 8? But it only told us 2 sides, so how did you know the third side? It is called a reflexive property. That is side, side, side. That's a good one. Number 9, they are right triangles. They are right triangles. There's only one theorem with right triangles. Eliza, what can we use on number, or can we use it on number 9? Hypotenuse, leg. Otherwise, it's angle, side, side. Normally, we can't use that. Normally, that's a no-no. But since they're right triangles, hypotenuse, leg works. Number 10. Number 10. They don't tell us parallel. On number 10, it's a bow tie. So which theorem usually do we use for bow ties? Yes. It didn't tell us a bisector, though. It's only vertical on this one. But they didn't tell us. All right, Allie, what did you think on number 10? Yes, there's definitely a vertical angle. I don't know why that one went red. There's definitely a vertical angle. It's not angle, side, angle, though, because they're not, the side is not in between them. So how should we write it? That's true. Those 3 things are true. What do you think, Allie? How should we write it? Yes. There's 2 options, either angle, angle, side, or you could have side, angle, angle. It doesn't matter. Okay, I'll just help you out a little bit. We don't have enough information on 11. It's not they're not right triangles. We only have one angle and one side, so you can't prove similarity yet. We would have to figure out something else. So look at the last one. Again, these little triangles or arrows mean that these are parallel. This picture, you can conclude a ton of stuff. So we might have a bunch of different answers depending on what you notice. So try this one. See what you think. Think of your reason why. Share with your neighbor. But again, because of what they've given us, we can conclude a lot about the angles. So these are parallel. We've got 2 different transversals. That's one transversal. That is a transversal. Okay, compare with your neighbor, because I'm curious. Again, lots of different answers you could have on this one. Tanner, what did you and your neighbor decide? Okay, tell me one other thing that you know is going to be congruent because of either the parallel lines or because of the bow tie way that the picture is drawn. Yes. Definitely we have a vertical angle, so now we've got angle, side, side, which isn't It's not enough, right? And what else is anybody else noticing? Deacon? Yes. Because we have parallel lines and a transversal, the alternate interior angles are equal. We've got another transversal, so these are also equal. We know all of the angles. So from here, you could choose angle, side angle, side angle, side. There's a lot that you know right now. Just don't use angle, angle, angle. Don't use angle, side, side. Okay. Oh, where's the other thing I was going to show you? This wouldn't let me present earlier. Oh, that's why. Sorry, let me see if I can fix this. Make sure it's big enough you can see it. Okay. Sometimes when we are showing that triangles are congruent, like that one we were just saying side angle, side, 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 side. But if I have to define specifically two triangles, you have to be able to name them properly. So can you guys see with all these pictures, which two are definitely congruent? So let's compare with this one specifically. What other triangle is congruent to this one? It's got 40, and then 60, and then a side that's called 7. Forty, 60, side 7. Is that 40, 60, side 7? No, they're switched. This is 40, 60, and a 7, but they're in a different order. So these two might be the same, right? These two might be the same, but they're not the same as that one. How about this one? It's been flipped around a little bit, but it's got the 40, and then the 60, and then the 7. And so that is angle, angle, side. We can say that they're congruent. So in order to properly write this, start with the first one however you want. I'm going to call it, oh, you definitely can't see that. I don't think you'll be able to see any of my markers on black. And this matters. If you're saying two triangles are congruent, they have to go in the same order. So I'm going to call it triangle ABC because it's alphabet. A was the 60-degree angle. So when I name this one, I have to start with the 60-degree angle, which is an N. B is the empty angle. So my next one would have to be the empty angle, which is M. And then C is the one with the 40 degrees, which is O on the corresponding parts of that triangle. So be careful with that as you go to name equal parts, that they match up with the, in this particular one, 60 degrees, 60 degrees. Empty, empty, 40 degrees, 40 degrees. Okay. I'm going to give you a paper. We're going to do the front of it together. Well, I'll give you time to work on it, and then we'll go over it. The back, until you get to number 11, we have not talked about number 11, so don't just cross off number 11. You're welcome. So at the top of this green paper, it says, let's see if I can get out of this. There we go. Is it this one? Okay. At the beginning, number 1 through 6, you are just stating whether they can be proven by side, 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 and side, angle, side, and then you're supposed to write a congruence statement. That's what this is. This is a congruence statement. So for example, on number 1, Davis, can we prove that these two are congruent from the markings they gave us? By which one? Is it side, 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 or side, angle, side? I don't either. And then you need to write triangle, and then you get to pick how it starts. I'm going to go clockwise. M, W, C. Now this one I have to be super careful because this triangle has been rotated. Can you see where it kind of came from? So I'm going to go P, Y. Oh, I forgot my triangle. So again, my first M was between a single dash and a second dash. So my first letter over here needs to be between the single dash and the double dash, which is P. Do you see how I'm deciding which ones correspond? Or if you're good at visualizing a rotation, if I go M, W, C, this one would be P, Y, F. Some of them, there's not enough information. You would just put like not applicable. You can't conclude anything. Okay, I'm going to give you a few minutes to work on these. If you are stuck, you are welcome to ask your neighbor, what did you put on this one? And then we will do the proofs down here together in just a few minutes. E, ace. All right, this one I've got side, angle, side. And again, you may not have labeled them exactly how I did. So I did tiny, big, neat. S, U, V. So if yours are in a slightly different order, as long as your S's match up with your S's, the T matches up with the U, the V matches up with the V, yours is also correct. We don't have to start with the exact same letter. They just have to match up as we go across. I don't know if that makes sense. This one's definitely side, side, side. So triangle, I'm going to go M, N, Q. If I started with this one and then went to N, I went past the single dash. So P, Q, N. It's hard when they've been rotated like that sometimes. All right, number 5, we know vertical angles. That is angle, side, side. So I don't have enough information to prove congruence yet. I would have to leave this one as it is. This one is a right triangle, but we don't know the hypotenuse. So we're going to have to use side, angle, side. So WXZ is how I'm going to choose to say my first one. If I started out here with W, I'd have to start out here with YXZ. Any questions on those top 6? Okay. Proofs. Does anyone remember what I do to start out my proof? Yeah. The given. There's 2 things I should do with the given. Write it down here. So we have a lot of given. AM is congruent to CP. CM is congruent to GP. Maybe I can bring that one up here. Oh, it's not going to let me. And C is the midpoint of AG. Given, given, given. That's the first step for everybody. Easy points. And if you wrote them all on one line, that's okay. I just can't with the big fat marker. I have to spread them out. So if you wrote all 3 things here and given, or maybe you had to use 2 lines, it doesn't have to look exactly like this. You just have to start with your givens. Camden, what else do you usually do with the given? What did I suggest you do with it? Yeah, look at our picture. It is empty. If your picture is empty, it's going to help very much to come over. AM is this one. It is congruent to CP, which is that one. This is going to be so helpful for you to see. Do I have sides? Do I have angles? CM is congruent to GP. And then they're telling me that C is the midpoint of AG. So step number 1 might seem kind of tedious, but it will help you move forward if you write it all down and then go mark it on the picture. Peyton, what do you think we're going to be able to prove here? Is this helping us with size? Is this helping us with angles? Yes, but we have one empty side. How can I show that they are congruent? They gave us some information, right? But Peyton, how do I conclude that? You know why I can say it? It's definitely not the same line. Alaska. Yes. They told us this was the midpoint. If they gave us the middle, it means that these two pieces are equal. So definition of midpoint. That's how we know it. Because they told us the dot is in the middle. If you're getting stuck on a step like that, use your purple paper. Your purple paper is full of statements and the reasons that match it. And now, like Peyton said, I've got side, side, side. And I don't have to be too stressed out about the statement because they showed me what I was trying to prove. I have done that, so just copy it down on the bottom line. And if you have empty lines, it probably just means you shoved your given on a 1. Lots of given. One thing we had to prove, and then we had all 3 sides. Okay, I'm going to walk around and just see how everyone's doing. You've got about 5 minutes to be working on these. Come with these as much done as possible so I can see where people are getting stuck. So please work all the way to the bell. And if you're done, you stay in your seat until everyone else is done. But make sure you do your givens, draw on the picture, and then see what you can conclude.